Okay, so let's say you have your survey data in Excel and you want to import your data in WaterGEMS for hydraulic modeling. Well, there are some few procedures that you need to go through to achieve that, and today that is something that we are going to cover. And if you are new here, my name is Engineer Lodrick, and this is Hydroinformatics Academy, a place where we discuss about technologies related to irrigation and water supply. So if you're interested about the topic that we are going to cover today, keep on watching. Okay, so this is our network. As you can see here, this is Google Earth Pro, and this is where our storage tank is located. Of course, we have some few junctions here. This is junction number 1, this is junction number 2, and also we have some few water points here, public water points. Okay, so we need to take this network and insert in WaterGEMS. By the way, if you don't know how to extract UTM coordinates from Google Earth Pro, I'll just make sure to include the link to that tutorial in the description below. And if you have your data already in Excel, then let's proceed. So for me, this is my data already extracted from Google Earth Pro, and this is what I have. So as you can see here, we have the UTM eastings, northings, altitudes, and of course we have some remarks here, or the name. Okay, so what I need to do is take these coordinates and make sure that I insert them within this template. As you can see, this is the template that I created for this network. Now here I have some few headings. This is the label, this is the X, this is Y, of course this is the eastings or X, and this is the northings of Y, and of course here is the elevation or the altitude, and again we have some remarks here. Below here you can see we have junction data. We also have the other worksheet, which is link data or the pipe data, and also we have a storage tank. Now for link data, we have again the label, starting nodes, or the starting node, the end node, and the diameter of the pipe, roughness coefficient, and material type. Also we have a storage tank with the following properties. Label, let me remove this data. So this is our tank, or this is our worksheet for tank. We have here a label, we have here the UTM eastings, we have the Y, or the northings. We also have the altitude, the elevation at base, elevation at the minimum level, initial level, maximum level, the diameter, and also remarks. Remember, these are the data that you need to obtain from your storage tank. We'll see later how it works. But for now, let me take my data and start with junctions. Okay, so let me go back to my data and start. Let me copy all of that, copy all of them, and let me paste. So let me take you back. We have here eastings, northings, and altitude. So let me copy them and paste at the appropriate columns. Okay, so these are the eastings and northings. So let me paste them here. Okay, so the first thing that I need to do is to clean my data, and to make sure that I have all of my data within the appropriate format. Okay, so let me start by cleaning. Okay, so let me remove this heading here. Let me remove this heading. Then this is the storage tank coordinates. Okay, so this is the storage tank coordinates. But before that, let me take this junction and paste it here, because this is where our junction is. Okay, so this is the coordinate for junction number 1. So let me take these coordinates for storage tank, and let me open the worksheet for storage tank here. Then let me paste here. So this is the eastings for tank, this is the northing for tank, and this is the elevation or the altitude for our storage tank. Now, before we even move further, let me insert here the label for my storage tank. Now for storage tank, I want to use the ST, which present the storage tank /1, because I have only one storage tank. Then it makes sense to use this one here. After that, what I need to do is to insert the elevation at the base, because this is the groundwater storage tank. Now the ground elevation will be the same as the base elevation of my storage tank. So let me click equal, then take this one here. Again, we have the minimum elevation. So if you have your tank, and this is the point where below this level water will not be available for consumers. So this is the minimum elevation. So I take this ground elevation and plus it with 0.3. So if water goes below 0.3, then water is not going to be available for people. So let me take this altitude and plus it with 0.3. So this is the elevation at the minimum water level of my storage tank. Again, we have the initial. So the initial water level will be the ground or the altitude plus 3. Okay, so this is my initial water level. Okay, so it is 3 meters from the ground. Okay, again the maximum level, this is important. Let me take this altitude, then I plus it with 3.3. okay, so the maximum water level for my storage tank is located at 3 meters above the ground level. So I take the ground level plus 3.3 meters. Okay, and again we need to specify the diameter for my storage tank. For my case, let me assume I have the circular storage tank with 8 meters as the internal diameter. Again, if you have any remarks or notes, you can specify them here. For me, I'll just write anything. So let's say this is 100 meter cubic ground storage tank. Ground ST storage tank. Now we are done with the storage tank. Let me move back to the junction data. Okay, so for the junction data, again I need to remove this one here. Okay, so again let me rectify this. So in nutshell, this is what we have. Okay, this is what we have. So if you look at it closely, we have our storage tank, which is this one, which in our network it is located somewhere here. We also have junction 1 and junction 2, which if I take you back here, you can see these are the coordinates for junction number 1, these are the coordinates for junction number 2, and also these coordinates here are the coordinates which can be found within this portion between the junction 1 and 2. Likewise, these are the coordinates for water point number 2 and this for water point number 3. But we need also to introduce the labels here. Okay, so these are the junctions for our network. We also need to introduce the labels for our network. Okay, so let me say L/1. Of course, feel free to introduce any label. The most important thing is that it needs to be something that you can remember. So if I drop here, this is what we have. Okay, this is what we have for now. And what I can do next, let me move straight to link or the pipe data. If you can see here closely, for now I don't have anything here, but the only thing that I am having is this one: diameter, roughness coefficient, materials, end node, starting node, and labels. So before we even start with labels, we need to familiarize ourselves with these few things. So the starting node is where the pipe is going to start, and the end node is where our pipe is going to end. Okay, so this will be the end node for our pipe, and this will be the start node for our junction, or for our pipe, sorry. Again, here we have the diameter and also roughness and material. So let's start here. If I take you back here, you can see the first point here is the storage tank, and the next point here is the junction. So this pipe here is what we are going to insert here. So the starting node is a storage tank, which for our case is ST number 1. Let me copy this, and again let me insert somewhere here. Then the end node, which for our case is junction number 1. So I need to find the label for junction number 1. Junction number 1, so the label is this one. Actually, we are not supposed to use L. Let me use the J1. So J for junction, L was not the right choice, so J. So the label for junction number 1 is J1. Okay, so let me copy and insert it somewhere here. Okay, so from junction number 1 to junction number 2, we have some few coordinates here. Again, if I take you back here to junctions, we have these coordinates here is what we are interested with. So from here, junction number 2, number 3, number 4, all the way to junction number 2, which has a label of junction number 5. So from here, what I need to do is to take this. So from junction number 1, which is the end node, again we need to start with junction number 1 again, all the way to junction number 2. Okay, and the end point is junction number 5, which is this one here, which is this one. Okay, which is this one. So what I need to do here is to, let me drop this all the way to junction number 4 and this one to junction number 5. Okay, so from ST1 to junction number 5, okay, to junction or to J5, which is technically J number 2, which is this one here. Okay, so from junction 5, J5, which is junction 1 technically. Now from here I need to go all the way to, I need to go straight to DP number 2, which is this one. So all the way to J number 9. Okay, to J number 9. So from junction 5 all the way to junction 9, which is the end node. Okay, junction 5, which is the start node, junction 9, which is the end node for this branch. Okay, again I need to introduce this branch as well. So from junction 2, which is labeled as junction number 5, all the way to this DP3 actually. So from J5 all the way to this DP3, which is labeled as J14. Okay, J14. Now from here what I need to do is to introduce here like J5, which is junction number 2, all the way to J10. Okay, J10. So all the way to, so from J5 all the way to J10. Now from J10, again from J10 all the way to J number 11. Okay, so let me drop this all the way to 13 and this one all the way to 14. Okay, so from J5, which is junction number 2, which is this one, junction number 2, all the way to DP3 with the junction label 14. Okay, so from J5, which is junction number 2, all the way to J14. Okay, so that is the first important stage. Again, we need to introduce the labels. Okay, so remember we are dealing with pipes or links. So for me, I think it makes sense if we use the L for link. So link number 1. Okay, so the label for this one here will be just like that. Okay, so let's talk a little bit about diameter. Of course, here you can put the default diameter that you want to use, but because we are dealing with a new water project, automatically for now we don't know the actual diameter that we need for our network. For that case, if possibly we were dealing with the existing water project, okay, possibly we will know the actual link diameter for our network. But for now, because we are dealing with a new water project, I don't think if it is ideal to include this diameter here, because what we need to do is to insert our network and start sizing and start performing hydraulic modeling to determine the actual diameter for our network. So for me, I'm going to remove this diameter here because I don't see if I need it. So the roughness, automatic, if you did survey, you know exactly from this, for this portion maybe you need the steel, and for this portion here possibly you will be needing the plastic pipes or the PVC pipes. So for me, I'll just assume that at this portion here I need like the steel with this has an William coefficient. Let me do this, and again the material here is steel. The material here is steel, and again here the same steel. Okay, so for now let me assume here we have a PVC, and again here PVC, and let me copy. Actually, Let me assume we have PVC all the way. Okay, so for this portion here we have steel, but this area here we have PVC pipes. Okay, PVC pipes. So for now, this is what we have. Okay, so after saving, I need to close this. I need to close everything. So let me open the WaterGEMS, and let me click here new. I just click yes. To insert data in WaterGEMS, what we are going to use is the model builder. Okay, model builder, and this is how it works. So at home, let me click the model builder. Make sure that you are at the home tab is activated. Let me click the model builder here. Again, we have some few other templates, but for now, let me insert a new. And this pop-up window is going to appear. What I need to do is to select the data source type. Okay, so the data source type. From here, I need to click drop down here. You can see we have several options here. So from shape files all the way to Excel data, the CAD files. But for now, what we are interested is to use the Excel data. Okay, so for now, if you look closely, you can see this version include the version 2013. So I need to select this. It seems as though it is the latest format. Let me select this one and browse. Let me find where my data allocated. It was this one. Let me select this. This was the file that I was working on. Let me select this. Okay, so it is here already. So if I click here show preview, you can see this is what we are having, right? This is what we are having. If I click links, if I preview, you can see this is what we have. And again, for storage tank, we only have one. And these are the data. Okay, these are the data. So what I need to do from here is to click next. And I need to specify the coordinates units. For now, I am using meters. Okay, then I need to click next. Again, I don't think if there is anything I need to change here. Then let me click next. Of course, we need to use it for the current scenario. And the map elements by key field, of course, we need to use the label. Then from here, I need to click next. This is what we're having. Remember, we had three worksheets. So the first one was for junction data, link data, and the storage tank. So let me start with the junctions. Okay, so if I select here junction, and we have here settings activated. So the table type we need to select. This is the junctions. So we need to select the junctions and also the key fields. Okay, so the key fields here, I need to select the label. Okay, the label, then the X field. Okay, we have here the UTM or the X. I need to select this, and the Y field. Also, we need to select this one. Okay, so you just make sure that the Y field and X field goes with the appropriate fields on your Excel. Now from here, increase this. So for now, we are having some few options here as well. So for label, I need to select the property. So for label, I need to select the general, then label. Of course, you can even click this, you will find it. For listings, of course, here I don't think if I have anything to change. I just leave the way it is. The altitude, I need to select the elevation. Okay, so the elevation will, I need to map the elevation column in my Excel with the elevation in WaterGEMS. Again, then notes, I need to select the notes. Yeah, let me click N. You can see this is my notes. So let me cross check for the last time. Label, the altitude went with the elevation in WaterGEMS, and again the notes or the remarks went with the notes property. So from junctions, let me move to links. Okay, for links, I need to select the labels again. Let me click arrow, find label, and again starting node, ending node, just leave the way it is. So the roughness, roughness coefficients, I need this also is very important. Okay, so it is this one here, Hazen-Williams C. So the roughness coefficients, it is Hazen-Williams C. Then the material, we need to find the material. The material, we need to map it. So the material from Excel, I need to map it with the material in WaterGEMS. Again, the roughness with the Hazen-Williams C in WaterGEMS as well. Okay, so let me select the storage tanks. Okay, before there is something here that we miss. The key fields, remember we are dealing with the link. The key field here, I need to set here to label, and also the start, I need to set here the start node, and for stop, we need to select the end node. Okay, then after that, I need to move forward to storage tank again. Here we need to make sure that we select the appropriate element or the appropriate parameter. So for now, it's not pipe. Okay, it's not pipe, it is a storage tank. So storage tank is located here, and again key fields, I need to select. So the key fields here, the label, and the X field for my storage tank, the X field is this one here, UTM Eastings, and again the Y field and that one. Also we have some few parameters here that we need to make sure that they are linked with what we have in WaterGEMS. So the label, let me select the label. Of course it's not important because we have it already, but anyhow, let me select the label. And again, let me move to altitude. I need to map it with the elevation, and again the elevation at base, we need to mark it with the elevation base. And again the elevation minimum, for elevation minimum, let me map it with the elevation minimum somewhere, this one here. Also we need to select the elevation initial, which is this one. And again we need to select the elevation maximum, which is this. And again the tank diameter, I need to specify the diameter for our storage tank, which is this. So I just make sure that I map the tank diameter in my Excel sheet with the tank property in WaterGEMS. Okay, remember the units are in meter. Of course I don't have anything to change. Of course for the last one here is the notes or the remarks. I need to select the remarks or the notes. Let me click N, and also this one. Okay, so let me cross check again. I don't think if I have anything that I missed. Link, I don't think if I have anything. Now each property in Excel is mapped with the appropriate property in WaterGEMS. Okay, now you can even have a preview, quick preview here. Okay, you can even have a quick preview, but I don't think if it is necessary for now. Okay, let me close. Then from here, if everything is okay, then we can click next. Then click next. Would you like to build a model now? Yes. So I want to build my model. Yes. Then finish. After that, click yes. Okay, let WaterGEMS do its thing. Okay, so as you can see, we have some few notifications here. So junctions, we have 14 junctions, 14 pipes. We have also this one, and lastly we have a storage tank which is created. Then from now I need to close this, then click yes. And this is my network. So if you can see here, what we have here looks similar with what we have here in our Google Earth Pro. Okay, so this was a storage tank, and this was 2 water points. So this is what we have. But if you can see, the properties here are quite small. Okay, quite small. So what we need to do is to find a way to increase these parameters. Like a storage tank here is quite small. The junctions are not even visible. So what I need to do is to increase this a little bit. Let me go straight to tools and select this one. So from here, I need to go to drawings and at least increase it to 10. Okay, you can just play with it, find something that will be appropriate for you. So for me, I just increase this ones 10, 10, then click OK. At least for now, it's coming. Let me increase a little bit, 15 for 15 drawings, then 15, then 15. At least now it is visible a little bit. Okay, so this was L1, L2. We have some junctions. If I scroll here, you can see again, even on our links or the pipes, we have also the length. Okay, so the length here is 375. Of course, as we all know that in WaterGEMS we have like two options. So the first one, so the two options to insert the length. The first one is by user defined, and also we have the scaled or the auto calculated length. So for our case, we don't need to use this user defined because already WaterGEMS has calculated the distance between the coordinates that we have inserted earlier. So for our case, for this pipe or link, this is our length. Okay, and so on and so forth. Okay, so this is what we have, but let me show you one thing. Now what if I change, like I change the this elevation here, data. Let me change this. Let me put here 0.77. okay, 0.77. Let me change just this just one property and see if and see what we have. Okay, so after changing, let me click save and close this for a moment. Let me go back here. For now, what we are having, if I go back here, you can see what we are having is if I scroll here, you can see this is the elevation, not the elevation. So this is the Y. You can see here we don't have that 77 here. But if I close this and I open my model builder again, and if I right click here and click sync into model, okay, you can see now all the changes that I made on my Excel sheet are now reflecting right in my WaterGEMS. Okay, right in my so if you can see here, a storage tank is updated. So if I close this, click OK. If I close this and double click here, you can see for now that 77 is here. Okay, so for now what I can tell is that for now it is linked with WaterGEMS. So any changes on that Excel will be reflected in WaterGEMS as well. So that is what I wanted to share with you. Possibly in the next tutorial, I'll try to develop further on this network, try to maybe optimize the model and see if we can do anything with this network. For now, thank you, and I'll see you in the next tutorial.